All right. Good morning, everyone. It is about 11:35 a.m. Pacific Standard Time, and the date is March 30th. We forecasted a major event in Tonga earlier this week. We actually the initial forecast was on the 22nd because we had an extended watch period due to a very massive coronal hole that turned into face Earth. I believe we did the forecast, and I said it would peak around the end of the week, which it did, and we did get a successful hit with that terrible event in Myanmar. That was a 7.7, I believe, originally. This is just the last 24 hours that we have up here on the map right now. So, and the main area, the area that we actually called out as being the highest risk was the Tonga Fiji region, this little region right here. And sure enough, the week's just about over. As we said, it would peak, and we did call out this very specific area. Another successful forecast. So the method is good. It's actually really good. It's you could accurately forecast quite often. And when there's a lot of at least an awareness in the earthquake, community, people that watch the stuff all day long, and I like the fact that we know how to discern the difference between a prediction and a forecast. And typically, you can't predict an earthquake, and that's something I think that is just universally agreed upon, is that you can't predict the precise time and location of an earthquake. You just can't, in the same way that you can't predict when and where exactly a lightning bolt is going to strike the ground or a specific location on the earth. However, metaphorically speaking, I like to equate it to forecasting thunderstorms, because a weatherman, a meteorologist, can tell you, hey, there's going to be thunderstorms in this general area, and if you're anywhere within like a 500-kilometer or whatever radius of this big broad area, you could see some lightning. He's not telling you that, the weatherman's not telling you that you are going to get struck by lightning or that it's going to strike right next to you or hit your house. But in geological terms, you are going to be in the region of a thunderstorm. And it's exactly, well, kind of different, but it's essentially, in essence, it is the same as what we do here at Quake Weather with the earthquake forecasting. I cannot tell you, I wish I could, I can't tell you exactly when and exactly where a large event is going to occur. But what I can tell you is that I can give you a time period spanning a few days usually. The last watch is an exception because we had a massive coronal hole, and it's very rare that I have a forecast that's just like a whole week. But I can usually accurately forecast within a few days when there's going to be a 6 magnitude or higher earthquake. And again, we choose 6 magnitude or higher. Anything less than that is not statistically relevant. 5 magnitudes happen way too often. You could throw a dart at a calendar and probably get it right half the time when it comes to 5 magnitude. And when it comes to location, again, it's really tricky. But I can give you a generalized area of where we expect to see increased seismicity. Now, in terms of forecasting just increased seismicity, not major events, the method is pretty much just foolproof. In other words, I can give you a time period and a region and tell you, hey, there's going to be increased seismicity here. And it's pretty much almost always true. Like it's so rare that that's not true. You at the very least, you might not see a big event, but you will see an increase in smaller events, and if anything, an increase in the magnitude in certain areas. And that's what we call forecasting. It's not predicting, it's forecasting, and we do that very, very high accuracy here at Quake Weather. We called out this area right here. I believe we put this area at I put this area at about a medium risk. I didn't see too much there pointing me to high risk, but again, if you go back to the live stream on March 22nd, which was the original forecast, I put up a spreadsheet and I actually put this area at the top of the risk. Now, granted, Myanmar did get a much bigger quake, and because it happened in a heavily populated area, the damage was much worse. It was very terrible. And typically, not always, but typically when we see 7 magnitudes out here, it doesn't really hurt anybody too much, and that's good to know. It's so I think they might get some tsunami warnings, but sometimes they don't. Sometimes they don't get a tsunami from this, or if they do, it's just some an extra 3 feet on a wave that was only 3 or 4 feet high to begin with. It's not that big of a deal. No damage, nobody gets hurt, everything's fine. Nevertheless, we can forecast these events quite often. Most of my following on the Facebook group that I have, and I don't really run the Facebook group too much anymore, but you can find it on Facebook. I believe it's also called Quake Weather. If you look at like my followers, it's a vast majority of them are from this general area right here, Southwestern Pacific. And it's because a lot of them are fishermen, and it's important for them to know whether or not there's a possible tsunami. So I've gotten a lot of thank yous and Christmas cards and stuff, even though they don't really celebrate Christmas. They're very nice. Some of them are are not so nice and very demanding and want to know more, and they want to know it now. And I understand, and I do the best I can. But yeah. So anyways, going back to this was the top area we called out, and it was a successful forecast. If you want to go, we can go back and look at why we were saying that. Is because we were seeing at the time, over a few day period, some rather large events. Like if we go back here, 23rd, and we had one on the 30th. There were more, and these were pointing at again, just to remind you, if you ever see 10 kilometer on the depth right here, that is a default value when USGS doesn't have any depth data for this particular event and this particular seismograph. So whatever the seismograph is doing, either the data was corrupted or it just doesn't record depth that well. And so it defaults to 10. So there's no way to know how deep it really was. Whenever it says 10.0, that is a default value. And it's going to look different now. But we did see some darker low pressure cell activity right there, if I remember correctly. Let's look at the current state of the, geez, another one right behind it, folks. So right around this area, there was a large X-class solar flare yesterday too, which is really interesting. It wasn't facing Earth, thankfully. It was a massive solar flare. It was so big. If that was directed at Earth, we would have been in big trouble. All electrical grids would have been down. We would have lost all our satellites, meaning we would have lost all our internet, and it would have been really tough, man. Good chance we would have been sent back to the, not the Stone Age, but at least like, the horse and buggy age, probably. And city's not a good place to be in a situation like that. But anyways, this coronal hole that's turning away from us now is the one that was causing all the seismicity, and this is exactly why we put out the forecast on the 22nd, followed up on the 25th, and then again on the 28th, and again right now. It usually takes about 3 days for these forces to get here, so I think we're at the tail end of it, since this is turning away from Earth, and it's probably about a 2-day period from center facing Earth to about where it is now. So, I feel like maybe we have another 24 hours of forces from this coronal hole, the interplanetary magnetic fields, and the alpha wave mingling that goes on. I think we probably got another day. I would keep it was just the same as the original forecast. I forecasted that it would start to wind down on Monday. That was an estimation. The estimation was spot on. I actually don't, again, those are estimations. They are not exact measurements. But I've been doing this for about 13 years now. So my estimations are usually pretty good. Sometimes they're off by a day or two. I wouldn't say 2 days, but sometimes they're off by a day, maybe every now and then off by a day, but pretty close and usually right, but not always. So we have... not looking forward to this. I will do another forecast tomorrow. Unfortunately, I'm going to have to do another one. Negative, when it's red, it's of negative magnetic polarity, and this is going to be an extension of the northern solar polar field. And typically the red negative magnetic polarity is actually stronger. However, from what I could tell, not nearly as massive massive of a coronal hole as this one over here, but still rather large. If this, hopefully this clears up and we get more coronal field strength in here, and this coronal hole shrinks before it faces Earth. But we'll have more. We'll have a clearer picture of what it might look like tomorrow, and then by the day after tomorrow, Tuesday, it'll begin to face Earth. So let's go to the OLR anomaly. Let's see what's going on today. Hopefully, unless this information, yep, it's from yesterday. So, well, that's the 30-day average. Sorry, let me go to the daily. Same thing. It's from the 29th. It's a shame we only get this updated once every 24 hours, and then it's even at that, it's kind of it's a lagging indicator, but it's still valuable. Nearly as valuable if it was updated every hour, let me tell you, but still valuable. And what I'm seeing here is kind of raising a brow over here is this area right here in the Philippines. So these dark red areas are what we want to look for, but we want to look for, again, like the three, there's about 6 or 7 things we look at in total, maybe even more, but like the 3 major ones to kind of correlate together, the kind of the trifecta of like a high level view of seismic forecasting is the OLR anomalies near plate boundaries, where there is also a low pressure cell during a period of time where the Earth is taking increased intensity from unmitigated solar wind, which emanates from the coronal hole. So there is a plate boundary right here. I'm going to zoom in on this area actually. So we got Tonga. I believe we did call out. I didn't call out. I can't remember. I think I might have briefly mentioned Myanmar again. Like when we reviewed this, this was not at the highest risk, and so, or at least it wasn't, in my opinion, in the highest risk. It was Tonga and Fiji. So. Anyway, if we zoom in here to the Philippines, let me go back to the 24-hour, just a 1 day. Don't want all magnitudes. That's mental. Okay, so nothing in the past 24 hours, except maybe that. And what is this? This looks like a 4.5 magnitude, 118 kilometers deep. So that's pretty deep. Possibly a blot echo. There's only one. I would put this area at medium risk. I wouldn't put it at such a low risk. We're still going to be experiencing the forces from that coronal hole that's turning away for the next, again, my estimation about the next 24 hours. And, you know, not far from the plate boundaries, especially in geological terms, it's basically on the plate boundaries. And so, and then if we look over here, let me get rid of this because that's actually not very helpful. So, we go back to the OLR anomaly. If we, yeah, we can't zoom in any further than this. But if you could see right there, right that area, that red area right there, that looks like right where that event occurred, right? It's just if we zoom out a little bit, see this is the area where I can't zoom in on the OLR anomaly map any further than this. But if you see that little strip, that little island strip right there. At the north end of it is where it's that deepest red color. And then if we come over here, look at that. It's basically right there. And again, since this OLR anomaly data is from yesterday, it's likely that that dark red spot is right there. This is a very useful tool, even though it's a lagging indicator and it's some time behind. You could still get a pretty good idea. So I maybe about 50-50, I would say that when you're looking at this map, because it's usually a day old, this data, when you see a large event near that red area, that usually, not always, but usually indicates that that dark red spot either grew, it either expanded, or it kind of moved and shifted. So, yeah, I would keep an eye on this area. Naturally, you're going to see, you know, aftershocks probably in Myanmar, and then I would imagine in Tonga, you probably still see some aftershocks. But see, look, this area really started to heat up. You see? And this is what we were looking at. This wasn't what we were looking at when we did the forecast, but I was seeing stuff like this. See, this all happened today. This all happened. Whenever you see them clustered up like this in one day, that's an even stronger indication. When we were looking at the original forecast, I believe we went 5 days. So 5 days is about the max when I look for a cluster of blot echoes. And we saw about this same number of these. These aren't blot echoes, but we saw about the same number of quakes above 4 magnitude that were, I remember they were very deep, most of them. They're about 500 kilometers deep, which is really, really deep. And suddenly, we got this large cluster of event. It just increased. They increased in magnitude, and they were getting closer and closer to the surface, and then pop. See, 35 kilometers, 35. That's a default value, so we don't know 35, 35. I wonder if that might be a default value too. That just doesn't, I don't know if I buy that, It's just all 4 of these were at the exact same depth, possibly, sure. And then 29 kilometers. So again, 10 is the default value, so I can't really count that as the lowest or the least deep or the most shallow, but this one is, and that was the largest event. So far at least. Could be another one. Let's look. Possibly some charged particles resting there. If this moves over a little bit further and goes into the area, you could see some aftershocking and maybe even another 7 magnitude. Hard to say. But yeah, could see some aftershocking there. This area is starting to show a little bit of strength, but yep, see, getting a little bit stronger from this one, but then it went deeper. This is actually much farther away too. So, well, in geological terms, they're basically in the same spot. So I would put them on medium risk too. I would medium risk there. A lot of pressure release with this and that. We're seeing this. This is so funny. This is such a straight line right here. Yeah. Not too concerned about this area as of yet. Let's look at the low pressure. So yeah, I would definitely put the northern tippy top of California and like the Pacific Northwest coast. If that, the U.S. West Coast, but in the north. So not really Southern California so much as this area right over here, which is Petrolia. Off the coast here, Petrolia gets tremors quite a bit, and more often than most, more so than most places in California. But we have this huge, massive low-pressure cell right here that's bringing particles down into here. If we look at the earthquake map again, yeah, see, that low-pressure cell is likely contributing to all this. Whether or not it's actually triggering it is hard to say because these are small. These happen every day. There's hundreds of these every day. Globally, there are hundreds of these every day, I should say. But if we look at the mean sea level pressure right there, I mean, that's dead on right there. If we look at the OLR anomalies, tiny little thing, but again, since this is lagging, maybe it's higher up here now. I don't know about that though, because if it was, I believe these events would be a little bit bigger. With such a big low pressure cell like that, combined with even a outgoing long wave radiation at that level, it's not dark red, but it's, if that was up here, I don't know. I imagine it would be a little bigger. Again, this is why we don't typically focus too much on trying to forecast smaller quakes, because they're not statistically relevant as far as forecasting. And if you say, hey, this 3.5 occurred right where I said it was 5 days ago, that doesn't really mean anything. It doesn't really help. So I don't know. Tough to say, but I would say at the very least that low pressure cell is 100% contributing to those events. And we still got another 24 hours of that massive coronal hole, like we said. And let's see, let's over the Caribbean, still acting up a little bit. Let's look at their area of the world. Not too much low pressure cell activity, but a lot of high pressure cells feeding into that area. Let's see. That's a big one. Wonder if there's anything popping up down there. Let's check out Africa. Nope, nothing yet. There is a big crack in the earth forming here in Africa, though. That's pretty concerning. It's not too far away from the world's scariest volcano. And then Japan, we did put Japan on low to medium risk. Let's go look over there real quick. See what that's like. Not too shabby. Not too shabby. I'd put that probably at a low risk. at risk, so it's possible. Definitely more possible than most other places, but low comparatively speaking to other. It's I I feel like trying to say low, medium, high risk is very difficult. It's not. It's probably not the greatest idea in the world. So maybe I'll just do something else. So it should probably just be high risk and then just elevated risk. Maybe I'll switch to that. But anyways, so we're going to be looking for aftershocking in these two areas. Let's see what else. Japan, low risk. I would put the risk much higher around off the coast of Oregon and Washington and the very tippy top of Northern California. I'd put a low, maybe medium risk right here on the West Coast over here, like the Chile, Peru, Argentina area. And again, even though we're not seeing a lot of activity right there, I would put Philippines at a higher risk than probably, Japan or the U.S. West Coast, and probably even the West Coast of South America, I believe. Just because we have that OLR anomaly right there. We did have that event. And then to complete that trifecta, there is look. If you look at that, that's not very big, but it's purple enough that to indicate to me, and we got this little swirling area right here, that it's going from high pressure and the big area between high and low pressure, which is this yellow stream, and it's feeding down into this dark area. So we have the low pressure cells, very small, but I would still say a little bit significant for sure. But then when you combine that with that dark red OLR anomaly right there, and the fact we're still getting forces from that coronal hole, I would keep an eye on Philippines. I think that's about it. I just wanted to follow up. We did have that Tonga. I just wanted to go over it real quick and show you guys the areas of that I'm looking at now. And yeah, I think that's about it. If you guys have any, if you like what you see here and you want to learn more, ask me anything you want in the comments. I'll respond. And if you want to support the channel, like, comment, subscribe, all that. I appreciate it very much. Quake weather out.